So this is the last one, the condition, the mixed boundary condition. So what it means by mixed, for example, we have without derivative, and also here we have the with derivative. But sometimes it can be like y prime 0, and also here is y1 plus no need plus lah, y1 equal to 0.5. Depends on the condition, but for this case the derivative at the xn. Okay, alright. Oops. Alright, so first by using the centered difference, okay, so multiply with h squared h over 2 to h squared, so 0.5 xi. Okay, and then we factorize. Negative 2 okay, positive, positive, negative, negative, positive, positive, negative, positive. Okay, right. Okay, so from the conditions, so we have to construct this timeline. H is 0.5, so x2 equal to 1. Okay, alright, so this is mixed, and the first condition without the derivative, this one without the derivative. So here yx not equal to 1, so y not equal to 1. So we have the answer for y not equal to 1. So you have to remember, So let's say your boundary condition without the derivative, so you can get the answer for that point. For this case, because of we have the condition without derivative at the x naught, so we have the answer for the y naught. But for example, if I change the question to y1 equal to 0.5, but we have the derivative is not equal to 1. For example, this is your boundary condition. So for this case, you will have the value at y2 equal to 0.5, but you don't have the answer for y0. Okay? So depends where depends on the derivative. Okay? Alright? So y0 equal to 1. So we need to find what is the y1 and also y2. And also from the condition given, so we have y1 plus y prime 1 equal to, so y1, 1 is y2 2h. Therefore, our y3 y2 plus y1. Okay, right. So we only need to find y1 and also y2 only. Therefore, we only need 2 equations. Okay, now back to the one that we have reduced before. So you need to ask yourself, if let's say you let your I equal to 0, so you will have, if I equal to 0, so you will have y negative 1, but you don't have the value at y negative 1. Therefore, you need to start your I with 1, not 0. x1, and our x1 is equal to 0.5. Why not 1? Okay. No wonder lah, this one. Why suddenly? This one should be xi, yi plus 1. Okay, so x1 and then y2. This one correct. So 5. Okay, so continue. X2. Okay, so x2 is equal to 1, and also y3 is equal to 0.5 minus y2 plus y1. Okay. Second equation. Okay, so we only need two equation because we just need to find y1 and also y2. So by using the calculator, oops, my answer is not similar. Wait, I need to check. Why my answer is not similar? One point 125 negative, and this one is 2 negative. Oops, this one should be negative 2.75, and then positive 0.4468. Another one is negative 7694. Okay, right. Therefore, by using your calculator, your answer for y1 is equal to negative 0.4468, and for your y2 is negative 0.7694. Okay, right. Okay, so conclusion. So for the BVP, it depends on the condition. So let's say the condition without derivative, so you will get the answer for the y0 and also yn. And for example, you have a Newman boundary condition. So both we have the condition. So in your timeline, you cannot get the answer for the y naught and also yn lah. And for this case, for example, for this case, for mix, because of you don't have the derivative at the first condition, so we will have the answer for the y naught but not for the yn. But if we change the derivative at the x naught, so you cannot find the answer for the y naught, but you can have the value at the yn. Okay, that's all for this chapter. All the best.